So let's practice some more. So here I have two functions multiplied times each other. I know the derivative of ln of x, so let's let that be u. I can take the antiderivative of the rest, which would be x squared times dx. So take the derivative, I get 1 over x dx. Take the antiderivative, so you increase the exponent, x cubed over 3. So let's put it together. So I have u v minus the integral of v du. Okay, so let's take some time to fix it up here. So I'm going to pull the 1/3 outside, and I'm going to cancel here, so I get x squared. Oops, that's kind of tiny squared. Okay, can I take the antiderivative of x squared? I sure can. So carry everything along. So carrying an integral of x squared would be x cubed over 3. So multiply times that, I would get 1/9 x cubed plus a c. Okay, so this I just did. So you know the derivative of arcsin. So let's let that be your u. So your dv is the rest. So your derivative is 1 over the square root of 1 minus x squared dx. Your antiderivative is v and x. So I put it together. So uv minus the integral of v du. Okay, it's looking kind of ugly here. So what can I do with this? Oh, this is, sorry, it's very messy. Okay, let's break that a little nicer. There we go. Okay, so can't take the antiderivative of them each separately, right? Because I've got multiplication in between. So I wouldn't necessarily try parts again right away. I cannot take the antiderivative of it, but I always want you to think, does u substitution work? So after can I take the antiderivative, like this one, then is u substitution an option? Then try parts, and we're going to have other techniques to come. But I think easy u substitution works. Remember, easy u substitution is let u equal the inside function. And so when I take the derivative, I get negative 2x dx. So negative 1/2 du is x dx. That's what the numerator is, right? So again, what I really don't want to see is these little dash lines to carry that along, right? You have to keep writing it. So I'm going to say negative 1/2 on the outside, and I'm going to put the u in, so I get 1 over the square root of u. So I'm just being careful, going a little slow, so I remind myself that this is u to the negative 1/2. Now carrying this all along, carry the negative 1/2. Increase the exponent, so I get u to the 1/2 times a 2 plus a c. And so finally, I'll get minus, and then I'll put the u back in, the square root of 1 minus x squared plus c. All right, let's go for this one. Again, I know how to take the derivative of this, not the antiderivative, so that's going to be my u. And I can see I'm going to be needing to use chain rule. So don't forget, the dv is everything that's left over, x dx. So the derivative is 1 over 1 plus stuff squared, so I'm going slow, times the derivative of the stuff, which is 2x. Here, the antiderivative will give me x squared over 2. So this dv, be careful of it, right? Whoops, I forgot my dx. Okay, so let me just write my du a little nicer. So my du turns out to be 2x over 1 plus x to the 4th dx, correct? All right, so let's put it together. So u v I guess I wrote them in the wrong order, right? So u v, right, was what I wrote and said that differently. Sorry about that. Minus the integral of v du. Okay, x squared over 2. And then I have this 2x, 1 plus x to the 4th dx. x to the 4th down here. Okay, so let's take some time to fix things here. So the 2's will cancel. So let's do that. Remember, you cannot pull x's out of an integral, but these two, this x squared and this x here, make an x cubed. The 2's cancel, so I get this. Okay. So again, cannot take the antiderivative of that right away. Don't try parts right away. Try to see if u substitution will work. It will. It does. So du will give me 4x cubed. You've done u substitution so much that you're comfortable with it, right? So I get x squared over 2, inverse tangent of x squared. So I'll get this 1/4 out on the front. Integral of 1 over u du. So carrying all this along. So I'd have a minus 1/4 ln of the absolute value of u. And just because I'm squished here for room, I'm just going to put the x's back in and put the plus c. All right, last one here. So all of this has to be my u. And my dv is just my dx. So du is 1 over x plus 2 dx, and v is x. All right, so I'm going to put it together. So I have u v minus the integral of v du. Okay, so let's kind of fix this up here. Is there something that could happen in here? So I've got x over x plus 2. Well, I know I've shown you a clever u substitution that could work here, but now let me show you this new trick that I want to make sure that you're using, because mathematicians like to use this because we like to make our lives easier. We like to add and subtract. So if I have x, isn't that the same as saying x plus 2 minus 2? It is, because these go away, right? So I'm going to take this integral part, right, this term, I'm going to say this x, I'm going to say is the same as saying x plus 2 minus 2. Why would I want to do that? Now I can separate this fraction. So again, let me carry everything along. So I can say this x plus 2 over x plus 2 minus 2 over x plus 2. So I broke the fraction up into these two terms. X plus 2 over x plus 2, that's just x. So I'm just going to go slow here. So I get integral, should have had parentheses here. This gives me 1. And then this is the same as saying 1 over x plus 2 dx. This here, if I do a little u substitution on, I just get 1 over u. So this carries along. Minus, make sure you put parentheses because this minus has to carry through. This gives me x. And then this here would give me minus 2 over u du. So finishing it off here. So minus x minus minus gives me plus. And this will give me 2 times integral of 1 over u gives me ln of u. Now finally I put the x's back in. So this carries along. Minus x plus 2 ln of, and the u is equal to x plus 2 plus c.